Hello everyone, am I audible?
Yes, sir.
All right. I hope everyone's mic is working today.
Yes, sir.
All right. Today is your Viva. Shafullah, Peer, your mic is working, right?
Yes, sir.
All right. Peer, your mic is not working. All right. How are you going to give the Viva then? I told you yesterday also.
So, is it now or in the end of the class?
It will be starting in 2 minutes. All right. First
Okay.
Viva, then class. Yeah. Okay. Let's start with this Viva. All right. Rahman, what is a parabola? I need the definition of a parabola. Okay. Shafullah, what is parabola?
Sir, can I say?
Yes, sir.
Yes, Rahman, please.
Sir, a plane curve that has equal distance from the center. From center.
From center. And isn't that a circle? All right. Anyone else? Saifullah, what about you? What is a parabola?
It is a symmetrical curve which
Which?
intersects a cone in equal halves.
Equal halves. All right. Mazia, yes.
Sorry, sir, by mistake.
Okay. No, I'm asking you, what is a parabola?
Sir, it is the set of all parts which are equidistant from a fixed point or point.
All right. And what is a hyperbola? Mazia, you need to answer this.
Yes, sir.
What is an
It
hyperbola?
is the set of all points whose difference and distance from the fixed point is equal, constant.
From a fixed point. All right. Veer, how are you going to answer? Okay, you solve questions. All right. I'll be giving you questions also. Rahman, what is lattice rectum?
The line segment that passes to the center. Yes, sir. The line segment that passes to either of the center of the foci, which is perpendicular to the transpose axis.
Right. Okay. Shafullah, what is length of lattice rectum in ellipse? I
It
need the
is
formula.
2b square by a.
2b square by a. Mazia, in parabola, what is lattice rectum? Length of lattice rectum?
Sorry, sir.
What is length of lattice rectum in parabola?
4A.
4a. All right. And Rahman, in hyperbola, what is the length of lattice rectum? Rahman, I cannot hear you.
Can you hear me, sir?
Yes. What is
2b
length of
square by 4m.
2b square by 4a? All right. What is eccentricity, Mazia?
Uh, yes, sir. It is the ratio of a distance from the center from one foci to another.
All right. What is the formula for eccentricity, Shaifullah? How do we find eccentricity?
For what, sir? For parabola or
Eccentricity,
ellipse?
parabola.
It'll be A.
E equals to A,
No. If C by A.
C by A. All right. And Rahman, for hyperbola, how do we find eccentricity? I cannot hear you.
Sir, same sir, C by A.
C by A. All right. So let's try a few questions. All right. Everyone has to solve this and send the answer in the chat directly to me. All right. What is the eccentricity of hyperbola whose vertices yes, Peer, that was latest rectum. All right, Peer, please solve this question and send me the answers in the chat. All right. Vertices is equals to plus minus 2 comma 0 and foci is plus minus 3 comma 0. All right, you have to find eccentricity. Last 1 minute to solve this question. After that, we'll move on. All right, next question. Find the coordinates of a point on the parabola y square equals to 18x, whose ordinate is 3 times the abscissa. All right. 2 minutes for this question also. Send the answers in the chat. Three times abscissa. All right. The ordinate is 3 times the abscissa.
So what is after 3 times of the
Abscissa. This is B. Abscissa. All right, next question. Find the center and the radius of the circle 2x square plus 2y square minus x equals to 0. Find the center and the radius of the circle. All right, so YY is over. Now we are going to start permutations and combinations. Here you need the answers. Yes, that's correct. All right. Not the first one or the second one, but the third one is correct. All right. In the first part, I asked about eccentricity. You sent me the equation, right? All right. Arrangements. You all remember the last class? I hope. Yes, Rahman, Shafullah, Peer, Mazia. No. Write down a question. How many arrangements of the word apple are there? How many arrangements of the word apple are there? All right, solve this question. Send me the answer. All right, how to solve this? We need all the letters. So there are 5 letters. So 5 factorial, but there are 2 p's upon 2 factorial. So 5 factorial is 120 upon 2. The answer is 60. All right, 60 words are possible. Next question. How many words can be created with the letters of the word equation? The first part, the words start with E. The words start with E and end with N. All right. Solve this question. Send me the answers.
So Wi-Fi is over.
Yes, Mazia, Wi-Fi is over. We have solved the question of permutation combination also. Okay, please send me your answers. Mazia, why were you not responding in the classes since 5 classes?
Internet. I'm in India.
All right. Okay, please try to solve this question. All right. Solve this question. Shaifullah, Rahman, Mazia, Peer. No, all right. See, you have to arrange the letters of this word equation. So there are 8 letters, right? In the first part, it says the word should start with E. So let's fix E here. So in remaining spaces, we have to fill 7 letters in 7 spaces. So the answer is 7 factorial. Alright, 7 spaces, 7 letters, 7 factorial. In the second part, the words start with E and end with N, right? So out of 8, 2 letters are filled. Remaining spaces we have 6. We have to arrange 6 letters. So 6 factorial. Alright. P not 6, 6 factorial is the answer, right? Because 2 spaces are filled by E and N. Alright. Next question. Write down bundle method. Right, bundle method. Or you can say keeping things together. Write down the question. A library has 3 mathematics, 2 physics, and 5 chemistry books. Which are to be arranged on a shelf. In how many ways? These can be arranged such that all books of the same subject are together. Right, first part says books of same subject are identical. The second part, books of same subject are not identical. Alright, the difference between 2 parts. All mathematics books are identical, absolutely identical. All physics books are identical. All chemistry books are identical. Here, even the same subject books are different. Alright. So how to solve this? Write it down first. Alright, then I'll explain. Write down the question. All right, everyone wrote down the question. All right. So the question says we have three mathematics books. All right. In the first part, let's call them M. Right? Three mathematics books, two physics books, and five chemistry ones. All right. The question says they are to be arranged in such a way that all the books of the same subject are together. Whenever you see questions like this, that some things are together, you use this method. This method is called bundle method. What we do is make bundles of the things that are to be kept together, right? As soon as you make bundles, you will count them as three different units, right? We are not focusing on what the insides of these bundles are, but just the bundles. So we have three things to arrange. So three things can be arranged in 3 factorial way, right? And the thing that matters here is internally, if they are exchanged, the positions are exchanged, there is no difference, right? Because all the things are identical. So the answer is 3 factorial. We created three bundles, three things to be arranged, 3 factorial. But suppose in the second part, where even the books are different, right? And you make bundles. Now also three things to be arranged, so 3 factorial. But here the three mathematics books can be arranged internally also, right? In this bundle, these books are also to be arranged, right? So three things, 3 factorial for this bundle only, 2 factorial for this bundle, 5 factorial for this bundle. So this will be answer in the second part. Is it clear to everyone? Rahman, Shaifullah, Mazia, Peer.
Yes, sir.
Yes.
All right. Okay, the last part. See, Rahman, as soon as you make three bundles, right? I told you to count them as three things, three different things. So to arrange three different things, we need 3 factorial ways. But if you pick up this bundle, right? Here there are three books, M1, M2, and M3, and they are different, even though they are of same subject, but they are different, right? So in this bundle, right, in this bag, they can be arranged internally also. Like M3, M1, M2 is different than M1, M2, M3. But in the first case, it was same, M, 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 right? It doesn't matter if you changes to this side. So for this reason, because the books are different, we have to see their arrangements also, in how many ways they can be arranged. So 3 factorial for 3 mathematics books, 2 factorial for 2 physics books, 5 factorial for 5 chemistry books in those specific bundles. Clear now, Rahman? All right. So let's try a question. A library has 3 mathematics, 2 physics, and 5 chemistry books, which are to be arranged on a shelf. In how many ways? These can be arranged such that mathematics books are together. All right. You have to see here. We only need to keep the mathematics books together. All right, not all the books. This is also two-part question. Books of same subjects are identical. Books of same subject are not identical. All right, try to solve this, then I'll explain. All right, I'll give you a few minutes. Just the only difference is here we need only to keep the mathematics books together. All right. Anyone solve the question? Rahman, Shaifullah, Mazia, Peer. All right. So again, in the first part, let's assume the books like this. Shaifullah will check now. All right, if the answer is right or not. We need to keep the sorry.
Yes, sir.
All right. So we need to keep the mathematics books together. So I made a bundle of them. Now, how many things are to be arranged, Shaifullah?
Only max, right?
See, the question says you have to keep the mathematics books together. So I made them in a bundle. Now you have
Yes.
to arrange this with this, right?
Okay.
Right? You have to arrange all of these things. Why I made a bundle of this? Because I cannot separate them, right? So all the mathematics books should be kept together. So I made a bundle and I count them as one unit. Now this is one unit, this is another, right? They can be separated. So 5 this and 3 this. So 8 things to be arranged. So 8 factorial. But 2 p's are seen. So divided by 2 factorial. 5 c's are seen. So divided by 5 factorial. This will be the answer of the part. In the second part, M1, M2, M3, P1, P2, C1, C2, C3, C4, C5. Again, we have to keep them together. Made a bundle of them. Now this 1, 2, 3, and 5 this. So 8 units again you need to arrange. So 8 factorial. Now there is no division because all the books are different. But these mathematics books can also be arranged in the bundle itself. So 3 factorial for them. This will be the answer to the second part. Is it clear, everyone? Shafullah, is it clear?
Let's explain the second part again.
Yeah, see, you had to arrange in total 3 plus 2 plus 5, 10 books, right? The condition was you cannot separate mathematics books. So I kept them in a bag, right? Now the bag will move with this remaining 7 things. All right. So in total you have 8 things to arrange. One this bag plus this 7 books. So 8 different things to be arranged. So 8 factorial is the answer. But in this bag itself, there are 3 books which can be arranged in 3 factorial way.
Yes, yes.
So clear?
Yes, sir.
All right, then let's move ahead. Next question. In how many ways the letters of the word imagination be arranged such that first part both A's are together. Second part, both A's, both N's, and all three I's are together. All vowels are together. All vowels are together, and all consonants are together. All right, write down the question and try to solve this. Send the answers in the chat. Rahman, have you solved this question? Rahman, have you solved this question? Not. Mazia, you have also not solved this question, and P too. All right, let's see. First, let's write down which letters are there. So we have 3 I's, right? 2 A's, 2 N's, and MGTO, right? These are the letters in the word imagination. In the first part, it says both A's are together. So we make a bundle of this, right? So how many units are there? 1, 2, 3. This is 4, 5, 6, 7, 8, 9, 10. Right? So 10 things to arrange, 10 factorial, but 3 things are same, so divided by 3 factorial. Here 2 things are same, divided by 2 factorial. Here 4 things are different, so nothing, we can multiply 1. So this is the answer to the first part. In the second part, they say both A's are together, so one bundle of this. Both N's are together, so one bundle of this. All I's are together, so one bundle of this. So 1, 2, 3, and these 4 things. So 7 things to arrange, 7 factorial. And now all these units are different, so no need to divide by anything. In the third part, they say all the vowels are together, right? So this I and A, one bundle. So this is 1 unit, plus 2, 3, plus 4, 7. So 7 factorial, but divided by 2 factorial for 2 n's, right? Into, in this bundle, in this whole bundle, this 5 things can be arranged also. So 5 factorial upon 3 factorial into 2 factorial. All right. In this bundle itself, 3 i's and 2 a's, so 5 factorial divided by 3 factorial into 2 factorial. Fourth part, in the fourth part it says, oh wait, I forgot the O here. This is also a vowel. This is the wrong answer. I forgot the O. So we need to make a bundle of 3 i's, 2 a's, and O, right? One bundle is this. So how many remaining letters? 5 plus 6. So 6 factorial divided by 2 factorial into 6 things are here. 6 factorial divided by 3 factorial. This is the answer to the third part. In the fourth part, all vowels are together and all consonants are together. 2 bundles. So 2 factorial into, for this bundle, arrangement is 6 factorial upon 3 factorial into 2 factorial. For this bundle, 5 factorial upon 2 factorial. This is the answer. All right. Shuffle of first part is right, second part is right. In the third part, I guess you missed, right? The internal arrangement. In the fourth part also, you missed the internal arrangements. Everything else is right. All right, Shafullah, is it clear?
Yes, sir.
All right. Let's solve few more questions. In how many ways can the letters of the word pencil be arranged so that N is always next to E? N and E are always together. Try to solve this.
What's after always?
Always together. The difference between two parts is here it says
No,
N
no.
always
In
comes.
option 1.
Yeah, in option N is always next to E, right? After E. But in second part, they are together. This can be NE or EN. It doesn't matter. We can count them in second part. But in the first part, N should come next to E, right? Just after E. So solve this. All right, let's see. In the first part, it says n should always come next to e. So we make a bundle like this. They cannot interchange, right? And the remaining letters are P, C, I, L. So 5 units in total. 5 factorial is the answer. In the second part, E and N come together, but they can be interchanged. So 5 factorial for all of them, but in this bundle, they can be rearranged. So 2 factorial. All right. Shafullah, you've also forgot the 2 factorial in this part, second part. And you wrote 6 factorial in the first part. That is also wrong. You have to make a bundle, right? They cannot be separated.
Yes, sir.
Yeah, let's try another question. How many words can be formed from the letters of the word daughter so that the vowels always come together? The vowels never come together. All right. Try to solve this. All right. So the vowels are A, U, E. The remaining letters are T, G, H, T, R. Right. So we need to keep the vowels together in the first part. So for the first part, let's make a bundle of them. So one unit is this, the remaining is 5. So 6 factorial. Into they can be arranged internally because they are different. So 3 factorial. Right, this is the answer to the first part. Shuffle absolutely right. In the second part, the vowels never come together. That this positioning is never acceptable. Right. So what we can do is, if we arrange all the letters and subtract the number of the words where the vowels are always together, then we'll get the answer to the second part. So total arrangements are, how many letters are there? 3 plus 5, 8. 8 factorial, right? Minus, if I do this, 6 factorial into 3 factorial. This is the answer where the vowels are never together. Is it clear, Shafullah?
Yes, sir.
Rahman, Mazia, Peer, I hope it is clear. Next question. How many different words can be formed with the letters of the word Mississippi? All right, Mississippi. And how many words four eyes do not come together? And this is the question. The last part of the previous question. All right. See, Rahman, this last part says the vowels never come together, right? So we don't want any case of where these three come together in a sequence, right? Right after right. So what we did is we arranged all the letters. We saw how many permutations are possible using all the letters. The answer is 8 factorial because 8 different letters are there. Now if I subtract the number of words where they always come together, so I'll get the answer where they never come together, right? That's what I did here. All the arrangements minus where they are always together. So I get 8 factorial minus 6 factorial into 3 factorial. All right, I hope it's clear. Try the next question. All right. So in this question we have 1m, 4i's, 4s, 2p's, right? So 11 letters are in total. So in the first part, how many arrangements are possible? So 11 factorial divided by 4 factorial into 4 factorial into 2 factorial, right? Because total we have 4i's, 4s and 2p's. So dividing by that. In the second part, they are asking in how many of these permutations 4i's do not come together. So let's calculate in how many 4i's come together. All right. So if I make a bundle of this, how many units I have? This is 1, this is 2, plus 4, 6, plus 2, 8. 8 factorial divided by 4 factorial into 2 factorial for 4s and 2p's. So this is where 4i's come together. But in the question they are asking 4i's do not come together. So if I subtract this quantity from this quantity, I'll have the answer, right? This is total arrangements 11 factorial upon 4 factorial into 4 factorial into 2 factorial minus all the permutations where 4i's come together. So 8 factorial divided by 4 factorial into 2 factorial. Is it clear, everyone? Shafullah, you again missed this 11 factorial upon 4 factorial into 2 factorial, right?
Yes, sir.
Yeah, rest of the answer is right. Rahman, is it clear? Rahman, is it clear? Is this NCRT question? Yes, Rahman, this is a question from the NCRT. All right. Is this clear till now, everyone? Okay. So you can finish NCRT till permutations. You can finish all the assignments that you get from us. All right. All the permutation questions you can solve now if everything is clear. All right. Now let's start with combinations or selections. All right. What is the basic difference between combinations and arrangements? Here, order doesn't matter, right? Suppose in a box, 3 things are there, 3 letters, A, B, and C, and I ask you to arrange them. Then A, B, C and B, A, C are 2 different things. But if I ask you to choose 3 things, then it doesn't matter if you choose A, B, C or B, A, C, right? You are getting these 3 only. So in choosing or selections, A, B, C or B, A, C, there is no difference. But in arrangement, there is a difference. All right. So this is the difference between arrangement and combination. Order doesn't matter. Okay. Write it down. Number of ways of selecting R objects out of n available objects is NCR. Alright, in the formula you remember n factorial upon n minus r factorial into r factorial. If you have to choose r things out of n things, then NCR. Alright, write it down, then we'll solve a few questions. Alright, so write down the question. In how many ways can team of 4 boys and 4 girls be selected out of 6 boys and 5 girls? Alright, so suppose in your school there is a quiz tournament and you have to send 4 boys and 4 girls as a team. Alright, and you have to choose from 6 boys and 5 girls. So you have to choose 4 boys out of 6 boys and 4 girls out of 5 girls. So for this part, the answer will be 6C4, right? 6 boys out of 4 boys. Sorry, 4 boys out of 6 boys, 6C4. And here 4 girls out of 5 girls. So 5C4. Why multiplication? Because you have to choose 4 boys and 4 girls, right? And whenever you use and, we need multiplication. So 6C4 into 5C4. Alright, simplifying this, 6 factorial upon 6 minus 4 factorial into 4 factorial to 5 factorial upon 5 minus 4 factorial into 4 factorial. Alright, so this is 6 into 5 upon 2 factorial into 5, and this 2 is cancelled. 3, answer is 75. So there are 75 possible ways to select 4 boys and 4 girls out of 6 boys and 5 girls. Is this question clear, everyone? Shaifullah?
Yes, sir.
Okay. Rahman, Mazia, Alvia? Okay. So please revise this till the next class and complete the NCRT for permutations. All right, and do all the assignments. We'll do further questions of selection